Okay, you got that?
Yep, got it.
Yes.
Okay, so we will say as t approaches infinity, e to the power negative bt approaches 0. So 1 plus a e to the power negative bt approaches 1. So therefore, ft, which is c over 1 plus a e to the power negative bt approaches c from below. So this is the upper limit. Am I right?
Yes.
Okay, now if a is greater than 1, there is a point of inflection. Okay, so now if you want to find the point of inflection, what must you do?
Differentiate.
Yes, you have to differentiate it twice. So I'm going to show you step by step how to differentiate it. You have to be very careful because there's a lot of unknown here. Okay, so we chain rule, we get f prime t. So bring down the power, copy down the whole thing. Power take away 1 times by the derivative of whatever inside, copy down the whole thing, times by negative b. Okay, so now what we are going to do is we are going to take out all the constant. So I got A, B, C. I batu campur, okay? Then e to the power negative bt, then divide by 1 plus a e to the power negative bt squared. Okay? So when I want to get my f double prime t, I'm going to use quotient rule. So I will let the ABC be outside. So my f double prime t will be ABC put outside. So you are going to use the quotient rule formula. Still remember the quotient rule? Okay. So your u is e to the power negative bt. Your v is 1 plus a e to the power negative bt squared. Okay, you differentiate this one by one. Yeah. Your v prime t is 2, copy down the whole thing, power 1, then multiply by a negative ab e to the power negative bt. Okay, after you have done that, you put it into your formula. So it's v u prime minus u v prime. V prime is this whole thing. You write into here. I have no space, so I don't write. Okay, then divide by v squared. Power 2 become power 4. Okay. So now what you need to do is you factorize. There is a B here. There's a BE here. Negative BE. So I take it up. And the common factor, another one is here. Okay. So I take it out. One plus A e to the power negative BT taken out. Then negative BE to the power negative BT also taken out. So the bracket remain. So times are. Okay, so this one taken out. So this one become 1. So you have 1 plus AE to the power negative BT. Okay, this one taken out. There's a 2 here. And there's another term. So minus, and there's an A here. Minus 2A e to the power negative BT. Close. The whole thing over 1 plus A e to the power negative BT to the power 4. Don't worry, I will not ask you to do this during the exam. Okay?
Thank God.
You thank God.
This is crazy.
If you say it's crazy, then you don't learn maths. You cannot do that is because you don't have the patience to write down the thing. Okay, so we know that all this cannot be 0. All this cannot be 0. Yeah. So the only one will be the inside here. So I will write down, because I want to find the inflection point. So I will write down, this is AE to the power negative BT minus 2AE. So I left with 1 minus A e to the power of negative BT equal to 0. Yeah. So this is to solve for F double prime T equal to 0. So I will have 1 equal to A divided by E to the power of BT. Am I right? So E to the power of BT is equal to A. So that means my T is equal to, what is my T equal to? Ln A over B. So when my T is equal to ln A over T, my F ln A over B will be equal to, I put into here. So it will be C divided by 1 plus A. What is your this one? E to the power of BT, negative BT.
Wait.
E to the power of BT is equal to A. So one over E to the power of BT will be equal to what?
1 over A.
Yeah, 1 over A. So I replace with 1 over A here. So I got C over 2. That's what I proved. Okay, so all these are very complicated calculation. You have to have very strong algebraic skill. Okay, so I'm just going to give you the general one. if I give you a logistic function, okay, this function have this special characteristic. Okay, look at the graph will have two asymptotes. One is the upper, the other one is the lower. This one is as x approaches negative infinity. So you see your e to the power negative bx will approach infinity. So therefore your ft will, your fx, okay, I will put x instead of t. Your fx, which is c divided by 1 plus a e to the power of negative bx, will approach c divided by very, very big, become very, very small. So you will approach 0. So we call this a S shape. Okay, and this is the upper limit, is c. And the inflection point will happen, the y will be halfway. And the x just now we find is ln A over B. So these are the special characteristics. There's an upper limit. There's an inflection point. So that means there is a time, or there is a point whereby it increasing at the fastest rate. It is always increasing. Unless I put this at negative, then it is always decreasing. Hello?
Yeah.
Yes,
So
sir.
this is, yeah.
Absolutely.
So now,
Yep.
can you from here sketch the f prime x graph? Can you please sketch the f prime x graph?
Okay.
You see how the graph's supposed to be like?
A bump. Is it like a hump and then like it flattens?
Okay, so this is the highest point, correct?
Yeah.
So you will go like that. Because your f prime x sine diagram will be like that. Your f double prime x sine diagram will have the point here ln A over B, correct? This part is concave. This part is convex. So it go up until you reach the maximum rate, then the rate become less and less until it becomes 0. Okay?
Yeah.
Can or not? Okay, so
Yes.
two important functions, the search and the logistic, the information, please. So just now we talked about the B, right? The B function, okay, let me talk a bit about the B function. The function about the B, okay, we have the BT equal to 3,000 over 1 plus 0.5 e to the power of negative 1.73t. Okay, may I know, based on the knowledge you have about logistic function just now, correct? May I know why our graph only show this part? Why our graph is not S-shaped?
This
Why not like that?
time cannot be negative.
Yeah, because the inflection point, correct? The BT at the inflection point is supposed to be C over 2. So it's 3,000 over 2. That is 1,500. So 1,500 is here. So the inflection point is here, cannot be. Are you clear? So that's why your graph is start from 2,000. So it doesn't show the inflection point. And inflection point must be ln A over B, correct? The T. So if I put ln A, my A is ln 0.5 over B is 1.73. And this one I get negative. So time cannot be negative. So in this case, it doesn't involve the inflection point. So that means the B never increase at the fastest rate. So the fastest rate is at the beginning. So they can ask you, for this case, they can ask you, when does the B increase at the fastest rate? And for this case, it is at the beginning. So you don't keep looking for this. You get me? So if it's a logistic function and it doesn't involve the inflection point, so the rate of increase will be fastest at the beginning. Okay? So next week, we'll discuss all the question on rate of change, optimization, and kinematic.
Okay.
Also all the review question. Okay? Okay, thank you, class.
All right. Thank you, Miss.
Thank you.
Thank you, Miss.
Thank you, Miss. Miss, can you give,
Yes.
please go to the previous page? I want to take picture.
Which page?
The e to the power of something, something, something.
This one.
Yes.
It's a very complex one.
Yeah,
Okay,
just
done?
want to try.
Miss Do,
Yes?
in the green part, like this page one, the green part, the 1 minus AE BT equals to 0.
Uh-huh.
Why is it equals to 0 though, like that for that part?
Oh, no, because I want to find inflection point. There. F prime T equal to 0, F double prime T equal to 0.
Oh, okay.
Because all these cannot be 0. You get me?
Yeah,
Hmm.
thank you.
Okay.
Miss Do, could you go to the slide with the graph on it? I just want to take a picture to make sure I'm doing correct.
Here.
Yes, please. Sorry. The slide for C, question C.
Will they
The
throw this
slide.
also in the SAT too?
Here. Is it
Yes,
this one?
yeah, thank you.
Okay. SAT 2?
No, yeah, will they throw something like this?
Why not?
Why not? For sure, you know, like,
Mm.
you know,
So if I
so-
say why not, that means it's for sure. Lor.
Yeah, great.
Okay,
Oh, Lord.
done?
All right, thank you, Miss.
Welcome.